Here we'll be looking at the basics of solving one-step equations. So taking equations and solving for something that's unknown. So first, to do this, we're going to look at an example and we're going to use money to help us kind of visualize what's happening with equations. So the problem says solve for x. And we have this equation, x plus 3 equals 7. Now, you may be able to figure out the answer quickly, but we're looking at this in terms of algebraic properties so that we can use this to solve more difficult equations. So we could say x plus 3 equals 7 is like we have some coin that we don't know what it is. We don't know how much it is, but we know that one of these coins plus 3 coins that we know, in this case pennies, equals 7 pennies. So we can think about how can we get this so we know just what this one is equal to. Well, here we have these 3 pennies. We don't want these here. We want to know just what this is, so we want to take these away. But if we take 3 pennies away from this side, this is an equals sign. We can't just take this away and say that it's still equal because it's different now. So if we take 3 away from this side, we also would have to take 3 away from the other side of the equal sign. So if we take 3 away here, 3 away here, we make an equal change. We see that this coin, x, equals 4 pennies. And algebraically what we did there is we took our 3 and we subtracted 3 from it. But because there's an equal sign, we did it to the other side as well. And 3 minus 3 is 0. And all we have left on that left side is x plus 0 equals 7 minus 4. 7 minus 3 is 4. And we see that here, x plus 0 is just x equals 4. So the basic idea of what we're doing here is when there's an equal sign, we have to do the equal things on either side of an equation, and we want to do it with the goal of figuring out what our unknown, our x is. So that's this idea here. Equations are equal on both sides of the equal sign. So if something changes on one side of an equation, the other side must have an equal change. So we're going to look at some examples of how to do this, not just with adding and subtracting, but also multiplying and dividing. So we'll start with that first one up there. Zoom in a little on that. So x plus 7 equals 13. Well, this is very similar to our penny problem. If we want to get x by itself, we have this 7 here that we want to move. So to move plus 7, or make it 0, we would have to subtract it. And to subtract that, we would do minus 7. We can put a little bar here to keep our sides of our equation separate. If we do minus 7 here, we have to do it to the other side as well. 7 minus 7 is 0, so x plus 0. 13 minus 7 is 6. X plus 0 is just x, so we have x equals 6. This marker's not working so well. So we have our final answer, x equals 6. We can also check our answer by plugging 6 back in for x. 6 plus 7, does that equal 13? 6 plus 7 is 13, so yes. Our check confirms that x equals 6. Now, what if we have subtraction instead of addition? X minus 15 equals 2. Well, we can imagine this being a negative 15. What do we have to do to make negative 15 be 0? Well, the opposite of subtracting is adding, so we would add 15. And if we do that over here, we have to do it to the right side as well of the equal sign. Negative 15 plus 15, we get 0. 2 plus 15, we get 17, and the x comes down with it. So x plus 0 is x equals 17. And again, we can check 17 minus 15, that does equal 2. So our answer is correct. So, put simply, if there's subtraction, we want to add it to make it 0 and move the number make sure to do the same on the other side. And if there's addition, we want to subtract it to make 0 so that we can get x by itself. But what happens if we have, we'll put a little divider there. What happens if we have multiplication? If we have negative 5x equals 15. Remember, this means negative 5 times x equals 15. Well, we have to think about what is the opposite of multiplication. That would be division. So what can we divide by to get rid of negative 5? Well, if we divide by negative 5, and we'll write this as a fraction bar, and we'll make our bar here. Negative 5 divided by negative 5, negative divided by negative is positive, 5 over 5 is 1. So this becomes 1x, but make sure we do it to the other side too. 15 divided by 5, negative 5, becomes negative 3. 1x equals negative 3. If we have 1x, that's like saying we have one unknown coin. That's just x. X equals negative 3. And we can confirm, if we plug negative 3 in, negative 5 times negative 3 is positive 15. So x equals negative 3. But what about here? Here we have a fraction. So what do we do with this? X over 6 equals negative 10. Well, this is the same as saying x divided by 6 equals negative 10. And we already talked about the opposite of multiplying is dividing. Well, the opposite of dividing is multiplying. So what we're going to do is multiply by that denominator. 6 divided by 6, or 6 times 1/6, is 1. Those cancel, and we do the same thing to the other side. Negative 10 times 6. We're just left on the left side with x, and on the right side, negative 60. And we can confirm again, if we look here, negative 60 divided by 6, 60 divided by 6 is 10, and it would be negative. So negative 60 over 6 does equal negative 10. That would be our check. That confirms our answer is correct. So the key with solving for x in these one-step equations is to get x by itself by looking at whatever's with x, doing the opposite operation to make it 0 if it's adding or subtracting, and doing it on both sides to get x by itself, or multiplying and subtracting, or multiplying and dividing, do the opposite operation so that the number with x becomes 1, and x is by itself, and then we get our answer for those. And remember, you can always check your answer by substituting x back into the original equation. So now try some of the practice problems. You won't be able to do them all, but try the ones that are like this, and then go on to the second video, which is multi-step equations.